Hi, and welcome back. Today we will be looking at formulas for circumference and area of circles. This is in section 10.4, and we begin with some definitions. A circle, definition of a circle, are all the points in a plane, that means it's flat, that are equidistant from one point called the center. The distance across this circle from one side to the other that goes through the center is called the diameter, and from the center out to the edge is called the radius. So you could see that the diameter is equal to twice the radius, or d would equal 2r. They are the same. And that distance around the outside has a special name. It's called the circumference. So as I was looking at this, I wondered, who was the first person to kind of look at circumferences? And I just Googled it, and I found that Archimedes, who was a scientist, lived back in 240 BC, was the first mathematician to come up with this number pi. And then Eratosthenes, if you remember, we used the sieve of Eratosthenes earlier this year to find the prime numbers. He was the first mathematician to calculate the circumference of the Earth. And about that same year, he used pi and the formula for the circumference to calculate the circumference of the Earth. And he was very close, by the way, to the actual circumference. So pretty amazing stuff. So here are the formulas for the circumference C of a circle. If you have the diameter, you just multiply the diameter times pi. C is equal to pi times d. Or if you have the radius, you know that twice the radius is the same as the diameter, so C is also equal to 2 pi r. Why do we split it up? I don't know. That's just how we do it. So you could use this or this. They are the same formula. And speaking of pi, we know that pi is irrational. That means its decimal goes on forever and never repeats. Well, what is pi approximately equal to? We say pi, we can approximate it as 3.14, or you can use the fraction 22/7. Of course, most people use the decimal because that's just easier to work with on your calculator. All right, let's do a couple of examples. In your book, on page 554, they talk about a crater that has a diameter of 170 kilometers, and what would be the circumference of that crater? So we just use this formula since we have the diameter. C is equal to pi times the diameter. We plug that in, we grab our calculadora, multiply that out, and have the circumference of the crater approximately equal to 533.8 kilometer. Why approximately? Because we are approximating what is pi. So that's pretty darn close. In example 2, we are given a circle has a circumference of 70 inches. What would the radius be? So if we have the circumference and we're trying to find the radius, we would use this formula. So let's plug and chug. C is 70, and it's equal to 2 times pi times r. So to solve for r, we need to divide both sides by 2 times 3.14. Well, I want to show you how to do that and how to be careful about that. When you have 70 and we want to divide it by this product, we can go ahead and plug that in. 70 divided by, now we want to use our parentheses here and go 2 times 3.14. And what I want to point out is that the entire quantity in the bottom needs to be in parentheses, or what your calculator will do 70 divided by 2, then it's going to multiply by 3.14 instead of dividing by it. So you need parentheses around that whole quantity and enter. And this question says find the radius to the nearest inch. So to the nearest inch, this would be about 11 inches. So the radius is about 11 inches. All right. I'm thinking maybe you have seen those formulas before, so this is a review. I hope so. We're going to move on to the area of a circle. To find the area of a circle, our formula is A is equal to pi r squared. Forget about this. That was just a mistake I scribbled out. A equals pi r squared. And if you do wonder where that formula came from, you can flip back one page in your book and look at this example here. They've shown how they've taken a circle, they've cut it into a whole bunch of wedges. They use 16. You can use as many wedges as you want. You place those wedges every which way, and it kind of makes the shape of a parallelogram. Do you see the parallelogram there? With a base of B and a height of H. Well, what is that base? Well, these parts of our wedges are the circumference. Circumference is equal to 2 pi r. Well, here's half of it. So what's 1/2 of 2 pi r? What is 1/2 of 2 pi r? Those cancel. It's just pi r, right? This is our base of our parallelogram. What is the height of this parallelogram? Well, that height is just from the center out to the side. So this height is the radius. So what is the area of a parallelogram? Base times height. So what is pi r times r? That's how we get the pi r squared. Kind of an interesting derivation there. All right. Another way that you can remember the difference between these two, because these two formulas, I'm going to grab my highlighter here. These two formulas get confused a lot. Why do they get confused? 2 pi r squared. They're very, very different, but they both have the same kind of symbols in them, right? And numbers. R squared, anything squared, like square feet, square yards, that always indicates an area. So that's one way that you can remember area is the pi r squared. Alrighty, let's take a look at example 3 in your book. Example 3 on page 555 states, find the area of the circle to the nearest square foot, and they give us a diameter of 26 feet. Well, we only have one area formula, and it involves an R. It does not involve a D. So from the D, we need to find out what would R be. Well, we know that twice R is equal to D, or half of the D would give us the radius. So if the diameter is 26, the radius would be half that, or the R is going to be 13. Once you know the R, then we can just plug into this formula. The area of this circle would be pi times 13 squared. Now notice, only the 13, only the R is squared. The pi is not squared. So when we figure this out, we have to do PEMDAS. PEMDAS is exponents first. So 13 squared is 169. And then we're going to multiply that by our approximation for pi, which is 3.14. And we would get an area of 530.66, and that would be square feet. We want this to the nearest square foot. This would round off to 531 square feet. So this is approximately equal to 531. And the way you can write square feet is like that, feet full square. Alrighty. Turn the page to example 4. The area of a circle is 72 square millimeters. What is the radius? So the area is 72. What is the radius? So let's plug in 72 for A and then solve to find the radius. So we have 72 is equal to pi times r squared. We want to solve for r. So what would we do here to both sides? We can divide by pi. Pi is just a number. So 72 divided by pi Now you might have a pi key, as I also have a pi key. If you use the pi key instead of 3.14, you might be off by just a decimal or two. It's okay to use the pi key. So here is our 72 divided by the pi. So we have 22.92 whatever. That's equal to r squared. If r squared is equal to this, what is r equal to? We need to square root both sides. Now notice how I did not clear my screen, and I'm not going to clear my screen. Now I'm going to take the square root, which my square root button is right here, square root, and then remember you have this on your calculator also. See where it says answer? When I do second that button and it says answer, it has put in this long decimal expression right there. I don't have to do it. And then just press equal. And so the radius of this circle is going to be about 4.8 millimeters. If we round that off, we'd get 4.8. So R is approximately equal to 4.8. All right. Our last example is example 5. These problems can be kind of fun, where you want to try and find the area of some figure, which is actually two different figures kind of put together. So in example 5, we want to find the area of this window. It's 4 feet wide, and it's 8¼ feet tall, and then it's topped by a half round. And what is the area of this window? So we've got two areas here. We have the area 1, I'm going to say, is a rectangle. So the area 1 is just going to do base times height because it's a rectangle. So this would equal 4 times 8.25. And we can find that in a minute. And then we have another area that we need to find. The area of a half circle is just going to be 1/2 the formula for the area of a whole circle. So a sub 2 is going to be 1/2 pi r squared. Why 1/2? Because it's just half of the circle. What is the radius? Well, this distance would be the diameter, and that's 4. So the radius would be 2. So this will be 1/2 times pi times 2 squared. And now we can grab our calculator. So the first that we want to do is 4 times 8.25. And we get 33 square feet. And then 1/2 times pi times 2 squared. Well, I can do the 2 squared in my head. That's 4. And I can take half of 4. That's 2. And I can even do 2 times 3.14 in my head. That's 6.28. But if not, you could plug that all into your calculator. So the area of the entire figure would just be the sum of these two added together. So this area will be 33 plus 6.28 or 39.28 square feet. That would be the area of the window. All right, I have included in this, number 32 is going to be an extra credit. Do you want to be the first one to send it in? If you get it right, showing me your work, you will get 1 point extra credit on the next test. All right, great work. Remember, we're having a homework quiz on Friday of this week. Take care.